right, so example C. This one is different because I've got the E here. So I don't know perfect powers of E because E is an irrational number. So anytime I've got an E, I know I'm going to have to take a log of both sides. So we need to isolate our E. And just like in a regular equation, you want to try and isolate your variable. In this case, that's in the exponent. So the first thing I'm going to do is divide that 3 that's attached to the front. So this is let's actually make this 135 so that when I divide I get an integer. Okay. So divide both sides by 3. 135 divided by 3 is 45. All right. Now we take a natural log of both sides. So because I'm using log base E, that translates into natural log, or ln. Okay, so my whole thing with exponents is they come down as powers. So this is 3x minus 5 natural log of E equals natural log of 45. But remember, we do that because this is 1. So we just have 3x minus 5 is natural log of 45. This is linear. What do we do to isolate x? Well, we're going to add 5 and divide by 3. So I add 5 and I divide by 3. So that's my value for x. Now, even though 45 is divisible by 3, I cannot simplify the 45 and the 3 because that 45 is inside of the log function. So my solution, there's two versions, right? There's the exact, which is what I found here. So log 45 plus 5 over 3. And then there's the approximation. Now make sure that you use the natural log key on your button, ln. So natural log of 45 plus 5 divided by 3 is 2.94. So that would be my solutions. Now it doesn't matter what base you use. If you're the person who only ever wants to use log base 10, you could have used log base 10 here. But because base E is one of our special logs, one of our special logarithms, I would really recommend using log base E, especially because when we do some word problems here in a little bit, you're going to be wanting to take a log base E to simplify your work.